Can humans survive on Mars? Humans cannot survive on Mars naturally, but survival is possible with highly advanced technology and carefully controlled environments. Mars is a fundamentally hostile planet, and every basic requirement for human life, air, water, temperature, and pressure, is either missing or exists in a dangerous form. The first major challenge is the atmosphere. Mars has a very thin atmosphere made mostly of carbon dioxide, with almost no oxygen available for breathing. This means a human would suffocate within minutes without life support systems. In addition, the thin atmosphere is not capable of retaining heat or protecting the surface from harmful radiation. Space agencies like NASA are already experimenting with technologies that can convert carbon dioxide into oxygen, but these systems are still limited and require energy to operate. Another critical issue is atmospheric pressure. The surface pressure on Mars is less than 1% of Earth's, which creates extremely dangerous conditions for the human body. In such low pressure, liquid water cannot remain stable, and it either freezes or boils instantly. If a human were exposed to this environment without protection, body fluids could begin to vaporize, a condition known as ebulism. Because of this, humans would need fully pressurized suits and sealed habitats to survive even for a short time. Temperature is another major barrier. Mars is extremely cold, with an average temperature around 60 degrees Celsius, and it can drop much lower during the night or near the poles. These temperatures are far below what the human body can tolerate. Exposure would lead to rapid freezing of tissues, and even machinery and equipment can fail under such extreme cold. Any human settlement would require constant heating, insulation, and a reliable energy source to maintain livable conditions. Radiation exposure is also a serious concern. Unlike Earth, Mars does not have a strong magnetic field or a thick atmosphere to block harmful cosmic rays and solar radiation. As a result, the surface of Mars is constantly exposed to high levels of radiation, which can damage DNA, increase cancer risk, and affect overall health over time. To reduce this risk, future habitats may need to be built underground or shielded using thick layers of Martian soil. Gravity on Mars presents another long-term challenge. Mars has only about 38% of Earth's gravity, and scientists are still studying how this would affect the human body over extended periods. Lower gravity can lead to muscle loss, decreased bone density, and changes in the cardiovascular system. While humans might be able to adapt partially, the long-term health effects are still uncertain and could become a major limitation for permanent settlement. Water is available on Mars, but not in an easily usable form. Most of it exists as ice at the poles or beneath the surface. Extracting this water would require advanced machinery, energy, and processing systems to melt and purify it. Additionally, liquid water cannot exist freely on the Martian surface due to low pressure, so it must always be stored and used in controlled environments. Food production is another complex challenge. Since there are no natural food sources on Mars, humans would need to grow their own food using controlled agricultural systems such as hydroponics. However, Mars receives less sunlight than Earth, and frequent dust storms can block sunlight even further. The soil on Mars is also not naturally suitable for farming without significant treatment. This means food production would depend entirely on artificial systems that must function reliably at all times. The Martian environment itself creates additional problems. Fine dust particles cover the surface and can interfere with equipment, reduce the efficiency of solar panels, and damage mechanical systems. Massive dust storms can last for weeks or even months, affecting visibility and energy production. These environmental factors make long-term operations more difficult and require durable and well-designed technology. Energy is one of the most important requirements for survival on Mars. A constant and reliable energy supply is needed for heating, oxygen production, water extraction, and food systems. Solar energy is an option, but it is less effective on Mars due to weaker sunlight and dust accumulation. As a result, nuclear energy is often considered a more reliable solution for sustaining a human presence. Distance from Earth also plays a major role. Mars is millions of kilometers away, and travel can take between 6 to 9 months. Communication between Earth and Mars is delayed by several minutes, making real-time interaction impossible. This means any human mission to Mars must be highly independent, with the ability to solve problems without immediate support. Companies like SpaceX are working on technologies to make Mars travel and colonization more feasible, but many challenges still remain. Finally, psychological factors cannot be ignored. Living on Mars would involve extreme isolation, confined spaces, and limited social interaction. The communication delay with Earth would make it difficult to maintain normal relationships, and the constant awareness of being in a high-risk environment could affect mental health. Long-term survival would require not just physical solutions, but also strong psychological support systems. In conclusion, humans can survive on Mars, but only through artificial means. Mars does not naturally support human life, so every essential need must be created and maintained using advanced technology. Instead of adapting to Mars, humans would need to recreate Earth-like conditions in one of the most hostile environments in the solar system.